now we come to the frequency response of a common emitter amplifier. So you know that for any amplifier, the characteristics you can study by plotting what is called as frequency response. Frequency response means you will see how the amplifier is going to behave for each frequency. So you will vary the frequency from low frequency to mid frequency to high frequency, and you note down the value of gain and you draw the graph. That graph is called as frequency response graph. Okay. So the voltage gain of the amplifier and the phase shift, which is depending on the frequency range in which the amplifier can operate. So I'm going to change the frequency and I'm going to measure the voltage gain and phase shift. So the voltage gain graph is called as frequency response graph. X-axis will be frequency, y-axis will be gain. Okay, same way for phase shift. X-axis will be frequency, y-axis will be phase shift in degrees. So frequency response graph will clearly specify the characteristics of an amplifier. So in general, to analyze the frequency response graph, I'm going to divide the graph into three portions: a low frequency, mid frequency, and high frequency. So for analysis is going to be very, very easy for me. So I'm going to consider the three frequency range: mid, low, and high frequency. And I'm going to see what is the response of the amplifier for the three specified frequencies as shown here. First one, I'm going to take mid frequency. The mid frequency means the frequency is stable. So the voltage gain is going to be constant. So the mid frequency, the voltage gain variation will not be there. I can say the voltage gain is stabilized, or I can say the Q point is exactly at the center. So the amplifier is going to be in the active region. So it is going to provide a constant amount of gain. The circuit is not affected by the capacitance in the circuit. Okay, so whatever capacitance is there inside the circuit, that is not going to affect you because this frequency range is very normal for the capacitor to react. So whatever capacitive reactance you get, it is very, very small and it is not going to affect your circuit. So you can neglect that. So remember, in mid-frequency range, the gain is constant. You have to understand this statement. And the capacitive reactance is very, very small and it need not be considered for all your analysis. Okay, so we are splitting the frequency response into three regions: mid frequency, low frequency, and high frequency. And we have seen what is the behavior of the amplifier in mid frequency. So next one, also all the capacitance have very small value and they are not considered in this region. We can say these capacitance effective is very, very small. I told you the reactance offered by the capacitance is very, very small, right? So that reactance is not large enough to have an impact on the gain. So that is why I said the gain is almost constant. The gain is almost constant. Okay. So next one is low frequency. In the low frequency range, your circuit is going to behave like a high pass filter. High pass filter means it is going to allow the high frequencies. See see this is low, this is mid, and this is high. So middle I told you the gain is constant. So gain will be constant. Variation irkad. Low frequency la I am saying the circuit is going to act like a high pass filter. High pass filter na low frequencies it will not allow. High frequencies it will allow. So slowly the graph will be increasing and allowing all the high frequencies. This happens in low frequency region. High frequency region la it is going to act like a low pass filter. It is going to block all the high frequencies. So the graph will be slowly coming down like this. So it is going to block all the high frequencies. So the amplifier response graph will be increasing, constant, decreasing. So the constant portion is mid frequency, the increasing portion is low frequency, and the decreasing portion is going to be high frequency. That is what you have to understand from the frequency response graph.